Okay, so we've got the second lesson of this unit where we're going to actually take the proportion skills that we learned in the first lesson and actually apply them to polygons, which means we'll actually be taking some of the algebra we've learned and apply it to the actual geometry involved here. Notice that we have cows here. They're disguised as poodles, but they're cows. The larger cow is twice as tall as the smaller cow, and the larger cow is also twice as long as the smaller cow. You'll notice that the larger cow is 8 units in height. The smaller cow is only 4 units in height. The larger cow is 6 units in length. The smaller cow is only 3 units in length. So the cows are in proportion to each other. There's a better view of that cow disguised as a pink poodle dog. Okay, corresponding parts of similar polygons. So in that diagram, those are similar triangles. That's how we write it. Triangle ABC is similar to triangle DEF. Symbols we've been using so far. Right, we've just added similar to our list. Of course, we've been using equal. Notice the symbol for congruent is taking the symbols for similar and equal, putting them together, right? Because congruent is same size and same shape. And then, of course, we've also used the symbol for approximately when we have to round things off. Corresponding angles are congruent. Notice angle A and angle D each have just one mark, so you know they're congruent. Angle B and angle E have 2 marks, so you know they're congruent. Angle C and angle F have 3 marks, so you know they're congruent. And then the corresponding side lengths are proportional by a scale factor of K. So I can take any 2 of those 3 ratios and they will form a proportion. So let's look at a couple examples. Are these triangles similar? Well, if they are similar, each pair of corresponding sides must have the same ratio. Now I've got to compare XY to RS, because if XY are the first 2 letters of one of the triangles, I got to compare them to the first 2 letters of the other triangle. If I reduce them, I get 3/5. Let's grab another pair of sides. Okay. 18 compares to 30. If I reduce that fraction, I also get 3/5. So far, so good. Let's see if it works for the third one. Right? I have to actually check all 3 pairs of corresponding sides. They all have the same ratio of 3/5. So yes, those triangles are similar. The scale factor is 3/5. Right? If I take any side on the original triangle, RST, and multiply it by 3/5, I get the corresponding side on the second triangle, triangle XYZ. So let's assume that these triangles are similar and then find the value of X. Now, when I write a proportion, I can grab any pair of sides I want So I might decide to pick MN and DE. And then I might pick NP and EF. Now notice I've got to be consistent. If I put MN on top, I put NP on top. I put DE on the bottom, I put EF on the bottom. I've got to compare corresponding sides, but I have to do it in the correct order. Okay, now I can do my substitution. Plug in everything we know. And now, what skill? I'm going to cross multiply. Find the cross products. 18 times x, 15 times 30, right? So there's my cross multiplying. 15 times 30 is where that 450 comes from. And now I can divide both sides by 18. I come up with 25. Okay, one last example. Quadrilateral bird is proportional to quadrilateral cats. Find the lengths of segment IR and segment AT. Okay, so what pairs of sides should I select? Well, I'm going to compare IR to AT. And I'm going to compare BD to SC. IR is 3x plus 1. AT is 2x plus 2. BD is 8. SC is 6. Cross multiply. Use the distributive property. I subtracted 16x from each side. I subtracted 6 from each side. Divided by 2. All right, x is 5. I'm done. Oh, wait, I'm not done. It didn't say find x. It said find the lengths of those sides. Take that 5 and plug it in. And so now we actually have those answers. Now for the IXL, just so you don't get a little bit frustrated, here's an actual screenshot of one of the questions. And if I was doing this question, I can compare side VW to side FG, and I get 3. Now, the problem is, if I'd done it the other order, if I put FG on top and put VW on the bottom, I would have gotten 1/3. And although I might have understood what you're doing, IXL doesn't want to go the other way. So whatever polygon they list first, put that on the top. Whatever polygon they list second, make sure that gets placed on the bottom. Right? 9 divided by 3 will get me 3. Now, if we were in the classroom and you said, hey, I'm going to compare 3 to 9, and 3 to 9 is 1/3, and I'm going to declare that, right? One of them is 1/3 the size of the other. I would know what you're talking about, right? It'd make perfect sense to me. I'd say, hey, good observation, kid. Hey, you're doing great there. You're a good student today. Good mathematician. IXL, right? It's picky. So you just kind of got to play the game the way IXL wants you to play the game. So we're going to head off to a beautiful sunset. And what's more beautiful than the color purple? So of course there have to be some purples. And what would be more fantastic than a purple cow? So there is a worksheet. And then after completing the worksheet, there's an IXL. Although if you really wanted to, I guess you could do it in the opposite order. But 2 different assignments keep you busy today and give you a chance to learn the material and demonstrate that you know what you are doing.